Welcome to GW Integrative Medicine, the podcast about disease prevention and health promotion from the Office of Integrative Medicine and Health at the George Washington University School of Medicine and Health Sciences.
I'm Dr. Lee Frame, Director of the GW Integrative Medicine Programs and Executive Director of the office.
And I'm Janet Rodriguez, the office's Administrative Director. Today we're going to talk with Sue Ishaq, PhD, who is the Principal Investigator of the Ishaq Lab and an Associate Professor of Animal and Veterinary Sciences in the School of Food and Agriculture at the University of Maine.
The Ishaq Lab investigates solutions for using microorganisms to resolve disordered communities and host health by increasing our understanding of the interactions between animal or human hosts and their resident microbiota. Welcome to GW Integrative Medicine, Sue.
Hi, everyone. Thanks so much for having me here today.
Absolutely. Thanks for coming on the pod. So, Our group is a little bit familiar with the gut microbiome, but I think it's always good to start at the basics. So what role do gut microbes have in creating beneficial compounds from the diet to help reduce inflammation and promote health?
Yeah, that's a great question. So we've known for ever, right, that fruits and vegetables are good for us. And most of the time when we think about the benefits of those, we're thinking about fiber or vitamins or other macronutrients, right, like energy, or things that can be converted to energy. But there's also this whole slew of compounds that are in fruits and vegetables that we can't really access without our gut microbes. And so the work that I've been doing as part of a collaboration for the last 5 years has been to investigate how some of our gut bacteria will convert compounds that are found in cruciferous vegetables, so things like kale or broccoli. We happen to use broccoli sprouts because the concentration of one of those is really, really high in those young broccoli sprouts. So we're investigating the role that some of these bacteria play in converting this compound that's in those sprouts into an anti-inflammatory that we can actually use to maybe reduce inflammation in the gut. So we're targeting inflammatory bowel diseases.
Yeah, that's fascinating. We actually have had Jed Fahey on the pod to talk about broccoli sprouts and sulforaphane. So hopefully our listeners remember a little bit about that, but maybe just give them a bit of background on these compounds. How do they come to be in these plants? What do we need to do to get them in our diet?
Yeah, sure. I actually work with Jed. He's a lovely person, and he's been researching sulforaphane and broccoli sprouts for decades. So I'm glad that listeners got to hear from him. So the compound that we're looking at in broccoli and broccoli sprouts, it's called glucoraphanin, and it's actually there as a way for the plant to ward off insect predators, especially when insects are targeting seeds or the very young sprouts. So the glucoraphanin and other similar compounds tend to be really, really high in cruciferous vegetable seeds and the first 10 days of life. And so if an insect comes in and starts eating those broccoli sprouts, it's going to release these little vesicle containers that the broccoli sprout has, and it's going to release glucoraphanin. And at the same time, it's going to release this enzyme that's in the plant, and it will start that conversion so that the glucoraphanin precursor becomes sulforaphane right inside that plant. And sulforaphane is not that great for insects, so it's very stringent because it has the sulfur compound in it, so it doesn't smell very good, and it's not very good for them. So you wouldn't think that we would want to eat this, but as it turns out, because biology is really weird, sulforaphane acts as an anti-inflammatory in humans and mice and other mammals. And in part, it's because it's a very reactive compound, so it likes to bind to other things. And one of the things that it really loves to bind to is reactive oxygen species. So if you've got colitis, or if you're having a lot of inflammation or some other gut issues, often you can cause physical damage to the cells that you have that are lining your intestines. And sometimes that just releases either excess oxygen or oxygen that's not really bound to other things. And so we call those reactive oxygen species because they like to bind to other things, and they can cause physical or chemical damage. And so if you have things like antioxidants or sulforaphane, this will sometimes bind to those reactive oxygen species and prevent them from causing those physical damage. So that's like one of the benefits of sulforaphane, but it's also known to sort of reduce the activity of your immune system, which is particularly helpful if you have this ongoing inflammation and you've got so much inflammation that it's actually causing some physical damage to your tissues. So you want to just dial that back, and sulforaphane can help you do that. And then there's even a third benefit in which sulforaphane can stop or reduce the growth of certain bacteria that we know can be pathogenic to us that might live in the gut. So by and large, sulforaphane is a pretty great thing to have in your digestive tract.
Agreed. Broccoli and broccoli sprouts and its related cousins seem to be one of those powerhouses with all sorts of health benefits. So what type of health benefits do we see in general from this, reactive oxygen species quenching and other methods of action?
Yeah, it kind of depends on how much you're consuming and also how you're preparing those broccoli sprouts. So this is where we start to get into like this fascinating world of cooking and cooking biochemistry. So if you just eat raw broccoli or raw broccoli sprouts, you'll get a small amount, maybe 15% of that anti-inflammatory. And as soon as you start chewing it, you'll actually release the chemical and the enzyme from their little vesicles. And so you'll start the conversion right in that broccoli sprout as you're eating those raw sprouts. So often people like them on salads and something else. And, that's pretty good. You'll absorb about 15% in your stomach, and it'll get into your bloodstream, and it'll reduce inflammation in a couple of different body tissues, particularly in the stomach. And then it also tends to get reabsorbed in the bladder. So it can be really helpful as a way to reduce inflammation in bladder cancer. But if you steam the broccoli or broccoli sprouts, so you're cooking them over a higher heat, you'll inactivate those plant enzymes. You'll cause them to denature, so they're not functional anymore. And so that precursor will stay in the diet. So like if you steam broccoli sprouts for about 10 minutes and then eat that in a smoothie or as a pesto or in whatever else that you like, that glucoraphanin precursor will stay in your gut because we don't produce the enzymes to do anything with it. That glucoraphanin will make it all the way to your intestines. And if you happen to have some of the bacteria that are able to convert this, they'll produce the sulforaphane right in your intestines. And in that case, you'll get those benefits localized mostly to your colon, but we're starting to look at the way that we can play around with that high heat, low heat, no heat treatment and see if we can get sulforaphane benefits to be targeted to different parts of the intestine. So if you needed something in the upper intestines, or if you needed something like right as your small intestine converts to your large intestine, or if you need something in the colon, could we cook broccoli sprouts differently in order to get those benefits to hit in different parts of your body?
That's fascinating. When I think about the gut microbiome and diet, yes, obviously I think about benefits to the intestines themselves, but I often think about things having systemic effects. Are you seeing something similar with that, or we haven't gotten there yet?
Yeah, we absolutely do. So you can absorb that sulforaphane pretty readily. Again, depending on where it's being created in your body, sometimes it'll work locally, or sometimes it's easier to absorb that systemically. But anytime you are reducing that reactive oxygen damage, anytime you're reducing inflammation, you do tend to have localized effects and then also systemic effects. So we can definitely measure sulforaphane or the end products of sulforaphane after it's been sort of used up in people's blood. And you end up seeing kind of these like other benefits for up to like 75 to 90 hours, give or take. Actually, Jed Fahey's done quite a bit of research looking at the kinetics of that. In people, usually we're really focused on the intestines in my lab.
Sue, what is microbiome stewardship?
It's this idea that if we're thinking about the long-term health of people or ecosystems and both, that we really need to think about the quality of those ecosystems, the way people are able to access healthy resources, and how all of those things contribute to which microbes we interact with on a daily basis, and whether we're able to recruit beneficial microbes or sort of avoid those negative ones. So this is like a kind of a really big concept, but it works pretty intuitively, right? So if we think about air quality or water quality, we know that clean air and water is good for us for a lot of different reasons. But we also know that if we are exposed to chemical pollution in the air or the water, that can do us great harm. And so that tracks as well for sort of microbial pollution. So in areas that may be next to sort of waste reclamation, you often find more microbes in the air, and those are not necessarily the ones that you maybe want to interact with. If we've got maybe sewage pollution that's getting into freshwater systems because there's no infrastructure for wastewater treatment in that area, you'll often see gastroenteritis go up. And so we know that basically microbes are the things that help connect us to each other in the environment. And microbiome stewardship is this idea that, like, all right, if we're thinking about conservation, maybe we need to add a microbial lens on top of it. And so I'm part of a collaboration that actually just got some funding to basically create a definition of microbiome stewardship, come up with some best practices, and basically start making that guidebook for policymakers to think about microbiomes and how we can access better ones, or at least avoid the terrible ones when we're thinking about public policy as relates to health and environment.
So does climate change play a role in this? Because I know that Dr. Emma Meyer talks about soil and how climate change is changing the microbiomes in the soil that are very necessary.
It sure does. Yeah, that's a great example. If we're thinking about soil microbiota, there's a couple of different, there's like so many things that soil microbes do for us, but the ones that I guess are most pertinent to sort of answering that are thinking about the way that soil microbes are helping us turn over organic material in the environment and recycle waste, and so that we can grow new products, but also in agriculture, we're thinking about the health of soils and having a functional soil microbiome so that we can easily grow plants in a more sustainable and sort of lower chemical input way. And so if climate change is changing the bacteria that are able to survive in different soils and changing the way that they function, our soils are going to be less functional for growing crops or for depositing carbon again. And that's really going to start affecting not only food production, but food security and food justice. So if you think about how many people around the world are subsistence farming or subsistence fishing or subsistence agriculture, right? Those changing climates and the changing environmental microbiome is going to affect their ability to grow or access food. And that's going to be kind of a huge social justice issue.
Mm-hmm. Sue, what is the Microbiomes and Social Equity Working Group? This is brand new, right?
It is brand new-ish. We're 4 years old this year. So it is currently an international, basically a research society that is comprised of pretty much anybody that's interested in microbes in some way, and also social equity or social justice. So this originally came about prior to my position here at Maine, when I was a research professor at the University of Oregon. And I was having a lot of conversations with architects and building designers who were really interested in this idea of the microbiome, but they don't necessarily have a background in it. And so my background is in host microbiomes and specifically how diets can impact your gut microbes. So I would have these conversations about the importance of diet and food access on your microbiome, and then connect it to their interest in spatial justice. So like where grocery stores are located in an area, thinking about food deserts and stuff like that. And so we were having all these conversations. And then I abruptly found myself in financial need because I was in a soft money funded position at the time. And so I proposed this idea to the Honors College there to teach it as a course. So over the summer of 2019, I taught 15 undergraduates who were some in biology and some in humanities about different topics relating microbes and social equity. So food access and food justice and gut microbiome was one of them. We also talked quite a bit about perinatal healthcare and sort of early life microbial exposures. We talked about building quality. We talked about environmental contamination and microbiome, all sorts of things. And as part of the assignments for this course, the students wrote essays. And at the end of the class for an entire week, we just smushed all of those essays together and recreated one very long document, which continued to get worked on. We scooched it down to about 2,500 words from its original 10,000, and that was published in PLOS Biology in the fall of 2019 under the title Framing Discussions on Microbes and Social Equity. And so that sort of concept paper helped lay the groundwork about all of these ideas and talked about the ways that we can rethink about our microbiome research and our microbiome education so that we can connect it back to sort of these real world situations and potentially have a beneficial impact. So this is partially born out of me being a gut microbiologist and thinking about all of the research I was doing based off of fiber and the health benefits of fruits and vegetables and other things. But that's not really new for us. And I can certainly publish on that for the next 100 years, but it's
Easily.
Never going to
we all
do
can.
any. Yeah. I hope so, I guess. I can publish on that all I want, but if people can't access those food items, then it's never going to do them any good to know that fiber is good for their microbiome, right? And so I wanted to be able to do more with my research, and the idea of microbes and social equity was born out of that. And so after the paper was published, by that time I had moved into my new position at the University of Maine, and I wasn't sure if that was actually going to be going anywhere, right? I had gotten sort of mixed reactions from people, and many people were like, this is very interesting, but I'm not sure that you'll ever be able to show a mechanistic connection. And so I was sort of assuming that it would just be one fun publication I did one time, and that would be it. And I was extremely pleasantly surprised to be wrong about that. So researchers started contacting me, the media started contacting me, asking for more and more information and what was next. And so in December of 2019, about 30 of us just had a Zoom meeting to chat about our sort of related ideas. And so some of these people were researchers that I had been previously working with or I knew as friends. Some of them were researchers that had been working in similar topics or it really captured their imagination and they wanted to talk about next steps. And so we sort of informally named ourselves Microbes and Social Equity Working Group in about December of 2020. And since then, we've grown to about 300 members globally from about 22 countries. So it's free to join. Anyone is welcome. We also have a mailing list for anybody that is interested in just hearing about our work,
right
but
now.
not necessarily being. Yeah, perfect. We're so happy to have you. We have open group meetings. They're always on Zoom so that we can facilitate our global audience. Where we have seminar series, we have symposia, we often co-write articles together, or we have little spin-off research collaborations. We are starting our sort of global classroom idea, so we're in the beginning phases of thinking about how we can consolidate all of the teaching materials that we already have for our individual sort of teaching portfolios and how we can basically help each other create better curricula around microbes and social equity. And then we also have just sort of social hours, because it's so important to just have this like downtime, and it's so important to have these casual conversations with your colleagues, because sometimes just being relaxed and talking about who you are and where you're at and what you're up to and what's exciting can help you brainstorm in ways that scheduling a meeting with a whole agenda sometimes doesn't accomplish.
That is so exciting. And I myself feel very similar. As much as research is so important, if we just do research and leave it there, it's not really going to move the needle. I've done a lot of my work in terms of outreach with social media and getting people knowledge. But like you said, just knowing that they need fiber in a lot of instances is not enough. And it's not just because people don't want to change, it's because they can't change. They don't have access. And until everyone has access to a healthy diet, we're going to continue to have a very sick country.
Absolutely. In one of the studies that I'm doing related to the broccoli sprouts, we have a human diet trial where people are eating steamed broccoli sprouts every day for an entire month. And at the end of the study, we asked them basically an exit survey. So what could we have done to make this easier? Was it easy or difficult for them to eat the sprouts every single day? And asking them what things basically acted as barriers to them. So in addition to the biological and the chemical and the microbiological information that we'll collect from people about what happens when they eat broccoli sprouts in their gut and their anti-inflammatories, we also want to know, like, feasibly, could anyone even do this? Because we're giving them quite a bit of broccoli sprouts. And you don't think about how much of an impact it is to just steam broccoli sprouts for 10 minutes in your day and then add them to something else. But if you're like me and you are busier than you can possibly fit into a normal work day, then you don't really have not sure if you're in the same boat, being in academia. But like, we have our day-to-day patterns, and we've got a time constraints, and we've got logistical constraints to work around. And if a health benefit or a diet change doesn't fit into your life very well, you're not going to be able to pick it up as a habit, no matter how badly you want to. And so we really want to understand what barriers people faced, because some people, the taste or the consistency was a huge issue. Some of them said volume was an issue, and some of them were okay with it. For some people, some of the side effects that they felt in their gut, like maybe more frequent bowel movements or more regular bowel movements, some people perceived this as a positive and some people perceived this as a negative, right? And so, again, like, we all know that broccoli sprouts are good for us, based off of this anti-inflammatory, but even I don't eat broccoli sprouts every single day. So we really need to understand kind of all of these other things that are impacting people's lives that are controlling how they make their health and their diet decisions.
Oh, well, I'm excited to hear that research. We could do that on a lot of different topics, but I think this is a really great one to start, because it could have such massive effects, and hopefully in a reasonable amount. Like, the nice thing about broccoli sprouts is you don't have to eat 20 pounds of broccoli. It's a much smaller amount. So it seems like it's possible. But then I still hear, a lot of times people just want to take a pill. What are your thoughts on that? Is that ever going to be the method here, or does this really need to come from the diet?
I like to hedge my bets. So So I always say, like, we're going to need both, right? My lab is focused on whole food strategy. And part of that is because if you are consuming broccoli sprouts, you're not only getting that glucoraphanin, but you're getting a little bit of fiber to it. Although if you're eating the broccoli sprouts, it's not a huge amount of fiber. If you're eating them, you're also getting vitamins, your minerals, and a whole lot of antioxidants and other, like, polyphenols. And there's just like a slew of beneficial things that you can find in there. And some of those are really important to encouraging certain gut bacteria to stick around in your intestines and to sort of induce them to want to make this anti-inflammatory for you in a way that you can sometimes get that if you take a pill that's just purified glucoraphanin, but you're not doing anything else to encourage those bacteria. And if they don't happen to be in your gut already, or if you have, maybe some other gut symptoms going on, and so it's a difficult condition for them to live in, having just that precursor is maybe not going to get them to actually want to produce it, because we're not entirely sure what the bacteria get as a benefit out of this yet. So it's unclear of when they're going to make this and when they're not going to at all. And so, I tend to be in the camp of, like, if you can eat the whole food, you should. But we also know that that's just not going to work for some people. And certainly for anyone that has gut issues to the point of needing surgery or potentially malabsorption, then eating the diet is maybe not going to have any impact for you. And you actually need to start thinking about a higher dose supplementation. If you're thinking about reducing anti-inflammatories and you actually need them to go to your stomach, or maybe you're thinking about this for bladder cancer and so you need that sulforaphane, then maybe actually taking sulforaphane as a pill so that you're getting it right into your stomach and absorbing it right away is actually what you want. And so I think there's like plenty of room for all of these strategies, because we're never going to find one strategy that works perfectly for everybody, which is partly why we haven't resolved inflammatory bowel disease simply by feeding everyone broccoli sprouts. If it were that easy, I would retire already. So,
Excellent. Well, speaking of research, let's think about what's coming down the pipeline. Is there any research out there that you're particularly looking forward to reading, or maybe you're hoping someone's going to do?
Ooh, that's a good question. The research that I'm looking forward to reading is everything that I've seen on social media in the last 5 years that I have bookmarked and still not found time to go back and read. So I do have a long list that I look forward to getting to. Yeah. Would we even be academics if we did not have a pile of reading that we couldn't get to? Yeah. So, a lot of those are related to helping me understand gut microbiome in different scenarios, thinking about how medical research is publishing about inflammatory bowel disease, how nutritional research is publishing just on the nutritional benefits of broccoli sprouts. I tend to also have a very long reading list because I'm thinking about gut microbiome, from these different aspects or from these different professions. And so I have quite a bit more reading than I probably need to do. But I also, I find inspiration from different fields of microbiology, because not everyone uses the same tools. Not everyone has the same conceptual framework or how they approach these problem-solving things. And then you just have these really cool storylines that you can find in different ecosystems or in different scenarios that you just don't find in what you do. And so I do have a background in animal microbiology and also some wild animal microbiology. So things like sampling the whale lung microbiome using drones that you fly through whenever they breach. Yeah, there's a really awesome video. There's a couple of researchers, of course, all of their names
are escaping me. What kind of witchcraft is this?
I know, right?
Yeah, it's really cute. They have a petri dish that snaps open when the drone flies through the plume whenever the whale breaches and exhales, and catches droplets, and then it closes the petri dish and flies back to the boat. It's the coolest thing to watch. Yeah.
Well, I'm going to have to send that to my husband, who is a microbiome researcher and also a drone enthusiast, because that just sounds right up his alley. And I'm sure everybody else is now Googling that video.
Yeah. As soon as we're done recording, that's exactly what I'm going to do.
Yeah, we can put it in the show notes.
Oh, that's wonderful. Well, that seems like a great place to end. It is all the time we have for today, but thank you so much for joining us, Sue. This was really enjoyable.
Yeah, thank you so much for the conversation. And always, I love to share my science. I love to always talk to people who are really enthusiastic about learning things and gut microbiome. So lovely to be here.
This is the GW Integrative Medicine Podcast from the GW Office of Integrative Medicine and Health.
I'm Dr. Lee Frame.
And I'm Janet Rodriguez. Thanks for listening.
The Office of Integrative Medicine and Health produces the GW Integrative Medicine Podcast with funds from your donations. Your generosity allows us to raise awareness of the benefits of integrating whole person care, including evidence-based complementary therapies, into healthcare broadly. Help us continue to grow the podcast by making a tax-deductible donation on our website, smhs.gwu.edu/OIMH. Click the Give Now button on the left. While you're there, sign up for our free monthly newsletter for even more evidence-based content, including free webinars.